this. Yeah, so I won't be able to finish this any one section today, but I will emphasize on the structure. Just like before with the confidence interval, I give you the structure first.
Just a quick question, Thomas. For the quiz that's due next Friday, is any of the material going to be covered in today's course or just previous materials?
It's previous one. Yeah, it's all confidence interval.
Okay.
Yeah. Okay. Just like when I taught you confidence interval, I taught you the structure first, and then I applied that to confidence interval for mu with sigma known. Now, once you get used to with the structure here, then we just hit it with if you remember the next week after that, we did mu with sigma unknown, and then confidence interval for P. Yeah, I still owe you confidence interval for sigma square or sigma. But for that, you need to program something to your calculator. I will show you later on, let's say around 11 o'clock, and I will put it in the announcement also. Okay, so please pay attention to your announcement. I want you to do it at home during this week, programming your calculator, and I will provide you with the video from YouTube. Somebody did the video already, and I will give you the link for that. Okay, but you need to do it at home later on though. Okay, so I still owe you, I think that's 7.5. I think that's section 7.5. I still owe you. We will do it next week together with this hypothesis testing. Now, let me start with this hypothesis testing. Yeah, again, the emphasis today will be on the structure with some little examples. And I picked from the handout I gave my class in the winter, and I basically copy paste from my handout, so you can see this is actually quite nice. You know that I will save this later on as a lecture note. So after the class, if you give me like around 10-15 minutes, you can upload this to your, you can see I upload these notes on the discussion board for today. Okay, now hypothesis testing consists of 6 steps, and the components are these 6 components here. Now, every time I ask you to perform hypothesis testing, I want you to provide me all these 6 steps. Okay, and not only all these 6 steps, you need to write that 1, 2, 3, 4, 5, 6. Okay, not just say claim, hypothesis, test statistic. No, you need to number it. Okay, 1, claim, 2, hypothesis, 3, test statistics, so on and so forth. Okay, so there are 6 parts here that you need to show. Okay, and it says here formal hypothesis testing because in reality, like when you are submitting or reporting hypothesis testing, people will actually show these 6 steps, or at least 5 steps, because there are times those statisticians combine the last 2 steps. Okay, they may combine the last 2 steps, but for you, I want you to separate them. Okay, now another warning that I would like you to know is that in the past, if you look at my old tests, remember at that time, for many years, I used table method, okay, such that when they use table method, then I will teach them using traditional method when it comes to hypothesis testing. Now, however, because since last year, I fully go to calculator, then the method we use in this class will be the p-value method, okay? Again, this is also because I have my pride. Somebody keep on saying, Thomas, you just don't know how to use calculator. Thomas, you just don't know how to use calculator. I say, I almost say that thing. I say, you know what? I don't want to sacrifice my students who have hard time to buy a calculator, but since somebody pissed me off, and I think the calculator is, TI-84 is a lot more affordable, then I can shift to actually p-value method. And it is a good thing though that this time we use p-value, we go to calculator, because if you ask me to teach critical value method using this online teaching, it would be too hard. Because I need to teach you how to look at the table, right? Okay, and when you are confused, then I have hard time to see what you actually look at. Okay, so p-value method will be really much on calculator. And of course, p-value method can also be applied since many years ago if you use Excel. Okay, so I understand for a lot of you just need to pass this class, but for me, I teach you this class for a purpose. I want you to be able to teach this, to use the material that I teach you in this class, okay? And even if you don't have calculator, I assume you should have a computer to work on, okay? And on every computer, there is something called Excel, okay? Now, so again, my mindset is like, if you go to work, they will give you what? Very likely they give you computer. Now, in that computer, what kind of software you have, which software you can use? Very likely Excel, okay? Now, critical value, you need to have the table, while p-value, you can just use Excel. And right now, you can use calculator. Okay, now let me start with the first one, the claim. What is a claim? A claim is a statement that has exactly one truth value. It's either true or false. Okay, in real life, a statement basically a sentence that either true or false, cannot be both, cannot be neither. Okay, so for example, today is Saturday. That is a statement, okay? That's a false statement though, okay? But there are some statements that is not, there are some sentences that's not a statement. For example, a question, okay? A question, for example, have you had your lunch? Are you doing okay? You know, those are questions, which is not a statement. Of course, implicitly from some questions, people make statement. When I ask you, have you had your lunch? Implicitly, I'm asking if you are actually having your lunch. I care, right? Okay, but a claim in statistic, for now, will be a statement that has only one truth, one truth value, either true or false. And we are not talking about any statements, okay? We will be talking about only statements related to population mean. We have two cases in the past, the one with sigma known and sigma unknown, or with population proportion, or with population variance, or either standard deviation. Okay, now a claim may be explicitly provided in the problem, otherwise need to be paraphrased. Now, don't worry, right now it may be still like a kind of like what is a claim, Thomas? You can see that explicitly in the claim most of the, in the problem most of the time. Okay, otherwise need to be paraphrased. Maybe we will work on this following example later on, but let me just show you this right now, for now. For example, question A here, a salesman claimed more than 1/4 of all customers buy his brand vacuum cleaner. So what's the claim? You know, it's clear right away, right? The claim is more than 1/4 of all customers buy his brand vacuum cleaner. That's it. Test part question B. Test the claim that the mean body temperature of adult humans is not 98.6 degrees. So what's the claim? The mean body temperature of all adult humans is not 98 degrees. You see? Likewise, question C. Okay, so this question A, B, C that I will ask you to work on later on, the claim is actually very explicit. Okay, you basically copy paste that. Okay, now second one, the one that can be confusing is on statistical hypothesis, or most of the time our textbook or in the actual report, they just say hypothesis. Now, here's the thing. From the claim that we have in step 1, we will develop two competing complementary hypothesis denoted H subscript 0 and H subscript 1. Okay, now H subscript 0 is read null hypothesis. In the past, also called original hypothesis. That is status quo. Is the hypothesis that contains equal sign. That contains equal sign, either equal to or less than equal to or greater equal to. Now, alternate hypothesis, the H subscript 1 is read alternate hypothesis, is also called challenging hypothesis, is the hypothesis that is complement to null hypothesis. And therefore is not containing equal sign. You will see that these signs here are complement in that order. Try to notice this. If the null hypothesis use equal sign, then the complement hypothesis will use not equal. If the null hypothesis use less than equal sign, then the complement will be greater than without equal sign. And if it is greater equal to, the complement is less than. Let me write it down here. It's a kind of like a side note. Maybe I use this color. So if the null hypothesis use equal sign, then the alternate hypothesis must be not equal. Okay. If the null hypothesis use less than equal sign, then the alternate hypothesis use the greater than sign. Notice that they are complement. Okay, and likewise, if the null hypothesis greater equal to, then alternate hypothesis will be less than. Now, by doing it this way, then one of them must be true, and the other one must be false. Does it make sense? Okay, we are trying to test this claim, right? Okay, we try to test this claim, and from each claim, it's either true or false. Okay, now the null hypothesis, alternate hypothesis try to accommodate those two truth value. Okay, it's if null hypothesis is false, then the alternate hypothesis will be the true one. If alternate hypothesis is false, then the null hypothesis is the true one. They are complement to each other. Okay, now some notes here. A claim for step 1, the claim that we get from step 1 may be null hypothesis, may become null hypothesis, may become alternate hypothesis. So differentiate the words claim and hypothesis. Okay, the claim may be null hypothesis, may become alternate hypothesis. Now, how do we know the claim will become null hypothesis or alternate hypothesis, Thomas? Now, we know it becomes alternate hypothesis if it does not contain equality. Okay, if it contains equality, if the claim contains equality, then the claim becomes alternate, becomes null hypothesis. If it does not contain equality, then it becomes alternate hypothesis. Okay, let's do one example that we have underneath here. For example, our question A. Question A. A salesman claims that more than 1/4 of all customers buy his brand vacuum cleaner. So step 1, claim. more than 1/4 of all customers buy his brand vacuum cleaner. Now then, in our step 2, when it comes to hypothesis, you have to write it this way: null hypothesis and then alternate hypothesis. And we actually write it on the top of each other. Okay? We write it on the top of each other. Now, I want you to give me where your thinking cap. When the claim says more than 1/4 of all customers, more than 1/4 of all customers, does it refer to mu or p or sigma squared or sigma? When we say 1/4 of all customers, does it refer to population proportion, population mean, population variance, or population standard deviation? When we say 1/4, nobody say anything? Okay, well, I answer it for you. Well, 1/4 refers to proportion, right? 1/4 refers to proportion. And then we will use P. Now it says more than 1/4 means more than 1/4. It means greater than, right? It means greater than 1/4. But when we say greater than 1/4, does it include equal sign? No, it does not include equal sign. No equal sign, right? Now it means this greater than 1/4 will go to alternate hypothesis. Okay, now the claim will be here. Okay, now I am not saying, again, I'm not saying that the claim will always go to alternate hypothesis. No, that's not what I'm saying. I'm saying the claim can go to either one of them depending on does the claim, the statement in the claim include equal sign or not. Okay, now from the claim we see here, it does not include equal sign. That's why it goes to alternate hypothesis. Okay, now then, because the alternate hypothesis is greater than 1/4, then the null hypothesis must be the complement of that. Okay, so once we get the claim there, then we go back to the other hypothesis that we didn't do. Okay, now let's go back to the theory. Now, in recent textbook, including our textbook, they always use equal sign for null hypothesis. Okay, compared to the old statistician, they still use equal sign, less than equal to, or greater equal to. Now, right now, they use equal sign only for the null hypothesis. Okay, now the reason for this change, I will explain later on when we get to step 3. Now, I personally, just like a lot of other old school statisticians, still use this equal, less than equal, greater than equal to for the null hypothesis to maintain the idea that the alternate and null hypothesis should be complementary. Okay, now you will see that our hypothesis should be written in this form. Okay, at least the one we have in this section. Our hypothesis should be written in this form, like you use braces here, left braces, and then the hypothesis should be written on the top of each other. Okay, with colon and then the parameter. What are parameters, Thomas? Parameters are either one of these four. These are parameters. Okay, and then equals, less than equal, greater than equal, and then the complement for the alternate hypothesis to a constant. Now, with that said, let's do more examples. Oh yeah, historically, null hypothesis and alternate hypothesis, H sub 0 and H sub 1, originally denoted by sub 0, sub O for original, and subscript A for alternate. Now, the thing is the O and A looks very similar, especially when they are tiny, when they are small. Then the notations evolve to the current style H sub 0 for original hypothesis and H sub 1 for alternate hypothesis. Okay, now that's a little history. So for example, all statisticians, including one instructor, one professor, I had all professor at USC at that time. At that time, she actually taught with H sub O and H sub A, you know. But again, when you write it so small, your O and A look so similar. Okay, that's why they changed it to the current style. Now that professor was an old professor though, so while I still respect his her opinion. Basically, we need to update our way of writing, and that's why we get to the current form. Okay. Now let's see if we look back to this question A here. A salesman claimed that more than 1/4 of all customers buy his brand vacuum cleaner. The first question you ask, you do is you answer the claim first. Usually it's just copy paste from the question. Okay, they usually say it explicitly. Okay, now if they don't, then we deal with that later on. Okay, if they don't say it explicitly, usually they say that the claim in form of question. But if they say it in form of question, then we need to rephrase the claim as a sentence, to be more precise, as a statement, okay, not as a question. Once we're done with the claim, then we do the hypothesis. Again, hypothesis should be written using braces on the left-hand side, and then the null hypothesis, alternate hypothesis should be stacked up. Okay, and then you have parameter, inequality sign, and constant. Now let's do question B. Test the claim that the mean body temperature of all adult humans is not 98.6 degrees Fahrenheit. Can you try that? So the first one, claim the mean body temperature of adult humans is not 98.6 degrees. And then hypothesis. must be braces, right? Null hypothesis, alternate hypothesis with colon. Then we read the claim again. First, the mean body temperature. It talks about the mean, so must be, the parameter must be the mu, right? The parameter must be the mu. Maybe let me use this color. Okay, and then when I read further, is not. Is not implies not equal to. Okay, no equal sign. So it goes to alternate hypothesis. Okay, so it goes to alternate hypothesis. That's the claim. Because in the alternate hypothesis we use not equal sign, then the null hypothesis should be the complement. Okay, and then how about the constant? The constant is 98 degrees. So this is 98.6 degrees. 98.6 degrees. Okay, so this is the constant. This is the inequality and equality sign. Okay. Okay, question C. Question C. A cereal company claims that the standard deviation of cereal in its boxes is less than 0.5 ounces. 0.5 ounce. So step 1, claim the standard deviation of the cereal in its boxes is less than 0.5 ounces. Should I say ounces or ounce? I think you should say ounce only, huh? Okay, and then hypothesis. We start with the braces, null hypothesis first, and then underneath alternate hypothesis with colon, not equal sign, colon. And then we see what's the parameter being used. It's about standard deviation. Okay, the notation for standard deviation is sigma. And then, how about the mean inequality? Mean inequality is less than. Now, less than does not include equal sign. Less than is notation here without equal sign. So it goes to alternate hypothesis. Okay, so it's less than the complement rho greater equals to, and the constant will be 0.5 ounce. So this is 0.5 ounce, 0.5 ounce. It just happened that of these three questions here, question A, B, C, all of the claim goes to, alternate hypothesis. But again, that's not true all the time. Depends on the wording of the claim. Okay, depends on the wording of the claim. Now, let me ask you to do some problem. This time, it gets longer. Next time it gets longer. Question 1. National Assessment of Educational Progress is administered annually to 4th, 8th, and 12th graders in the United States. On the math assessment, a score above 275 is considered an indication that a student has the skills to balance a checkbook. That's actually a skill that we have hard time to see recently. Okay, now harder time to see recently. Now, in a random sample of 500 young men between ages of 18 and 20, the mean NAEP math score is 272. Now, do we have evidence to support the claim that young men nationwide have a mean score below 275? Now, notice that they don't really provide the claim in a sentence, in a statement, but they actually provide the claim in a question. Do we have the evidence to support the claim? What claim? Young men nationwide have a mean score below 275. Okay, so their claim actually provided to us explicitly, but they put it in a question. Now, you with your English skill, unfortunately, that's something I don't teach. But I don't teach, but I assume from you. You should be able to actually extract the claim from the question. Okay, so let's start. Step 1, what's the claim? The claim is young men nationwide have a mean score below 275. Then from there, we do the hypothesis. Hypothesis, start with braces. Null hypothesis, alternate hypothesis, stacking each other with column. Then young men have the mean score. Oh, okay, they're actually quite nice to give us the keyword, the mean. Okay, so that's about the parameter is mu below 275, which means less than, which means no equal sign. So it must be alternate hypothesis, 275. Then null hypothesis will be the complement of that, greater or equal to 275. But maybe from here, let me write a note. I'm okay if you use, for the null hypothesis, mu equals 275, like our textbook, as in our textbook. I don't want to mark it wrong. That's just about style. Okay, that's just about style. So if you want to use equal sign, for your null hypothesis instead of something else, like greater equals to in this case, you are fine. However, your alternate hypothesis has to be like this in this question. Okay, has to be like this. Old statistician, new statistician, recent statistician, like long time ago statistician, all of them still agree that alternate hypothesis, the one without equal sign, has to be written this way. Okay, the different opinion that is evolving in the past and now is on the equal sign here. Okay, my opinion my opinion is I want to keep them complement to each other such that the claim is either true or false, and it will either belong to null hypothesis or alternate hypothesis. Okay. However, the newer generation, the one who use equal sign, they have their own reason too, which we will see in step 3 later. Okay. Now let me ask you to try question 2 and question 3. I will give you 5 minutes from now. Let's start. The National Center for Health Statistics reports that the systolic blood pressure for males 35 to 44 years of age has a mean of 128. That's the report. Now, in a study of business executives, a random sample of 100 executives has a mean systolic blood pressure of 134. Do the data suggest that the mean systolic blood pressure for business executives is higher than 128? Oh, by the way, I would like you to realize the following. Things that I don't like, but I have to do it this way is this. A statistic is a very, very applicable skill. Okay, it's not just a course. It is the purpose is actually to develop some statistical skill for you. It is very applicable, such that in the end you will see you will be provided word problems, that's life situation, and at times the wording can be confusing. I give you that. Okay, that's why I personally will avoid writing the question myself, and I usually copy paste from whatever I can get online. Of course, I change the number a bit. Okay, so it's not exactly the same with the problems you see, but, or maybe instead of, for example, instead of using National Assessment of Educational Progress, I say that local assessment, SAT, whatever. Okay, yeah, so I may change those parts, but the wording in general stays the same. Okay, that's to cover my, I don't want my lack of preparation in English actually make you confused with your with the wording of the question. Okay, now at the same time, of course, if somebody criticizes me for, Thomas, I don't understand your English simply because I'm an immigrant, you know what, I will say that to that person, I take this question online. Okay, so that's not my own question. Okay, so please do not ever bring that to me. Thomas, I don't understand the wording, because it simply means something has something to do with your English. Okay, I don't want to attack you on your English. Please don't attack that my English for that. Okay, there's a minimum required English reading comprehension required for this class. Okay, so I use problems from other source that I know is pretty clear. That's one. Second, because it is in word problems, sometimes you have to organize the informations on your own. And if you think about it, it is actually part of statistics. Okay, we are not always given the data in already structured, well-defined, and they will tell you what is the mu or what is the sigma, what is the p. No, the notation p, mu, sigma, those things are notation that we learn from statistics to apply. Okay, but to apply in our real life, but we don't expect our real life problems will also tell us at the same time those p, what is the p, what is the mu, what is the sigma, so on and so forth. No. Okay, and if you think about it further, when we get hired, when we work, especially for somebody else on statistics, our job is actually to organize the data. If the data already well organized, they don't need us, right? They don't need us if they already have that well organized. In fact, we get hired because we solve the problem, not becoming part of the problem. Okay, so please have that mindset that one of the things I would like you to have, at least like for you to, when you transfer, okay, is that, you know what, I need to be part of the solution. And when I go to university, I will be given problems and I will be the one solving it. Okay, now if you are expecting that they provide you well organized informations, then trust me, you will forever expect the same thing. And who will be the one organizing for us, right? No, you want to be above the curve. If you want to be above the average people, then you need to do better. And one of them is to be able to do this. Okay. Now, I'm saying this not to discourage you that, oh, Thomas, it will be hard. No, no, no. Consider this as part of your learning process. Okay. Consider this as part of your learning process. And it is doable. Of course, it does take patience. Okay. It is doable. I sometimes think that those people who don't do well in this hypothesis testing, usually those people who are not patient with themselves. Okay. I think I'm patient enough, but of course you still need to do your stuff, right? Okay. Now enough for that kind of lecture. I want you to realize that you should not get discouraged with the wording, but you need to practice. Keep on practice. Okay. If your English is pretty good, I'm not saying that mine is good, but mine is now better because I practice. Okay. And you can be better than me if you practice. Okay. So not to talk down on you, I'm saying that you can be even better than me. Especially most of you actually born here or grew up here, right? So your English should be better than me. Okay? Yeah. Let's do question 2, the claim. Do they give us the claim explicitly? Yeah, kind of, right? Because they actually word it in a question, but do the data suggest that the mean? They don't use the word claim explicitly, but do the data suggest that the mean systolic blood pressure for business executives is higher than 100.8? Okay, let me just copy paste that. The mean systolic blood pressure for business executive is higher than 128. So then hypothesis will be null hypothesis, alternate hypothesis, about mu, right? The mean. Okay, higher than 128, again, is without equal sign, so greater than 128, then this one here is less than equals to 8. Okay, I hope you find it to be simple enough for now. It will get more complicated, but not that much, not that much, not that much. Okay, like question 3. Step 1, the claim. The claim will be the mean amount of active ingredient in all dosages produced is different from 8 milligrams. By the way, I think I took these 3 examples, question 1, 2, 3 here, at least question 2 and 3, from a program at some university, but I remember the level was MPH. That's a course for Masters of Public Health. Okay. Now, I'm not saying that this is for masters, but basically when those Masters for Public Health students taking classes, they need to deal with these problems. Okay. So it's not really about stats at that time. It's about your stats foundation and apply that to your major. Okay. Now, of course, I can change this into art. Somebody say, I'm an art major. I actually read it on Facebook. Somebody, I have a question. I'm an art major. Do I really have to take stats? And then I actually throw in a question related to art at that time. Okay. And to be honest with you, those artists who are actually making good money, believe it or not, they are actually, most of them have a pretty good math background. Okay, to my surprise. Okay, claim the mean amount of active ingredient in all dosages produced is different from 8 milligrams. It's a long sentence, huh? Thomas, do I have to write all of them? The answer is yes. Okay, that's why when I write the problems in your test, especially, I try to find the claim that is short enough, okay, so that you don't need to write long, but at the same time, still pretty clear. Hypothesis. No hypothesis. Ultimate hypothesis. It's about the mean. Different from. The word different from means not equal to. Therefore, the null hypothesis is equal to. Okay. Now, for now, all the claims seems to still go to the alternate hypothesis. All the claim seems to still go to the null hypothesis. Okay. To alternate hypothesis, I said wrong, but it's not true. It may go to null hypothesis. Now, let's go back to the procedure. Go to step 3. Test statistics. Now, since we will deal with parameters only, then we will deal with only population mean with sigma known, and then population mean with sigma unknown, and population variance or population standard deviations. For that reason, the test statistic we deal with will be either one of these 4 formulas. Maybe look this way, so it's better see. Oh, what happened? I'll keep it that way. Now, this formula here, this formula that we have here, this formula for population mean with sigma known, population mean with sigma unknown, population proportion, and population variance, actually closely related to what we had learned in confidence interval. Now, in confidence interval, we have margin of error equals to critical value times sigma over square root of n. Okay, now, if we see this margin of error as the margin of error refers to the difference between the sample mean and the population mean. This is the case for confidence interval. Remember when we did confidence interval for mu with sigma known, the margin of error has this form, right? This is in our step 2. Okay, now then I say, oh, margin of error is actually saying the difference between the sample mean and population mean. Now, divide both sides by the standard error. if you divide both sides by standard error, then you will get that the critical value, the test critical value will be x bar minus mu over sigma over square root of n. Okay, now, but in hypothesis testing, we will call that test statistic. Okay, so we will then ignore this. Not that we ignore that. In the past, we know the critical value from the confidence level. Right now, we use this same formula. If you think about this, this is actually the C-score formula, right? This is the C-score formula for sample mean. Okay, this is the standard error for sample mean, right? Okay, so if you memorize the formulas or the structures of confidence interval in the previous chapter, then the test statistic actually similar. Okay, the test statistic is similar. If we take a look on this one, for example, here, in confidence interval case, our margin of error was T critical times S over square root of N, right? Okay, now with the margin of error is the same to X bar minus mu. Now, therefore, if I change this to the test statistic T, that will be the margin of error, which is X bar minus mu, over the standard error, sample standard error, right? Okay, now that's for the test statistic. I said underneath here that the distributions of test statistics, here corresponds to the distributions for critical value we use in case of confidence interval. Okay. Now, the parameter used in those formulas, what parameter? I'm referring to this one here. Okay, in case of population mean for sigma known, it will come from whatever constant in the null hypothesis in our step 2. Okay, constant in the null hypothesis of step 2. If we look back here, it refers to the constant in the null hypothesis of step 2. Oops, that's way too dark. Constant of the null hypothesis in step 2. Which color should I use? I think I will use this one. The constant in the null hypothesis in step 2. Constant in the null hypothesis in step 2. Okay, constant in the null hypothesis in step 2. Okay. Now, in our next examples, we will apply steps 1, 2, 3 on hypothesis testing for population mean. Only step 1, 2, 3 for now, where the mu, population mean mu, with sigma known. The wording of these problems is edited to provide only relevant information to do step 1, 2, 3. So there are actually more information from the original problems, but I edit them. Remember, I told you that these problems I get it from internet, right? Okay, but I edit them such that we have only relevant information. Okay, because if I put all the information, you may get confused, right? Now let's see example 1. Let's do step 1, 2, 3. Okay, so we just learned step 3, but we don't want to forget step 1 and 2, right? Okay, so let's do it again. A principal at a school claims that the average IQ of students in his school is above 100. Now, a random sample of 40 students' IQ score is found to have average of 125. Now, suppose that the overall IQ scores have standard deviation of 15. Okay, so if I write it aside here, that the n, the sample size is 40. Okay, and then of this 40, the average is 104.5. While the overall standard deviation, means the sigma, right, is 15. Now, what is the claim? Oh, the claim is this. The claim that the average IQ score students in this school, in this principal school, is above 100. So step one, let me use another color. So claim. The average IQ score, IQ of students in the principal school in that principal school, to be more precise, is above 100. Step 2, hypothesis. Hypothesis, alternate hypothesis, mu is greater 100. Therefore, this is mu less than equals to 100. Now, let me say it again, that if you write null hypothesis mu equals to 100, it is okay. Okay, then let's go on. Step 3. And how about test statistic? We are testing the mu, and the distribution we use for testing mu is either standard normal or t distribution. Standard normal or t distribution. But because we know the sigma, the population standard deviation, then we will use standard normal distribution if the sigma is known. Okay, so C, the test statistic, is equal to the x bar minus mu over sigma over square n. Okay, which is equal to, now let's see the wording. What is x bar? The sample mean is 112.5, and the overall mu, the comparison will be 100. Now, remember I said that in our hypothesis test, in our hypothesis testing, in recent textbook, including our textbook by Crayola, they always use equal sign, okay? With me, I still use equal, less than, greater than for null hypothesis, right? Okay, but why do they change it to equal sign? Now, the reason they change it to equal sign, because that's the number they use, the constant of the null hypothesis in step 2. Remember that? The constant of the null hypothesis in step 2. Now, that's the number they use in their test statistic. That's the number they use in their test statistic. Okay, now that's why they actually write it as equal to instead of less than equal to. Okay, over 15 divided by square root of 40. Then you can use your calculator to compute this. But when you use your calculator, be very careful though. Okay, make sure you use parentheses. It's supposed to be written this way: 112.5 divided, subtracted by 100, but you need to use parentheses here. Okay, the difference divided by the quotient, 15 divided by square root of 40. Now you need these parentheses. You need this parentheses for the top. Okay, and then you need these parentheses for the bottom. Okay. Use your calculator, please. 112.5 minus 100 divided by parentheses 15 divided by square root of 40. Okay, I get 5.27046. That's for the test statistic. Okay, now remember, when you use your calculator, be very careful with order operations. And therefore, you need to use that grouping symbol parentheses by. Okay, that's for question 1. Let me go on to question 2. Question 2. Suppose we want to test whether or not girls, on average, score higher than 600 on the SAT verbal section. We also happen to know that standard deviation for girls' SAT verbal section scores is 100. A random sample of 20 girls give us a sample mean of 641. Okay, so let's start the cleaning. Girls, on average, score higher than 600 in the SAT verbal section. Girls, on average, score higher than 600 on the SAT verbal section. Second hypothesis. Alternate null hypothesis, alternate hypothesis. This is the average, so that's about mu. Higher than 600, so it's more than 600. This is less than or equals to 600. Again, I need to emphasize that if you write null hypothesis mu equals to 600, it's okay. That's the textbook style. Okay, then third, statistic. We are testing mu, the mu in the hypothesis, null hypothesis constant. That's the mu. How about the sigma? Well, the sigma will be 100 in this one. The sigma will be 100. Right? How about the n? This is the n. Okay, but because we know the sigma, then we will use standard normal, z score, not t. We use t if we don't know the population standard deviation, and we replace that by sample standard deviation. X bar minus mu over sigma over square root of n. That is, what is the sample mean? The sample mean is 641. Right, that's the sample mean. Minus the mu. The mu is 600. Divided by sigma, which is 100 over square root of the sample size. Okay, I hope my color don't confuse you. Instead, you know where I get those numbers from. Now then, this will be computed. Let me just compute it all at once. 41.4. I get 1 point. Sorry, oops. Get 1.83358. That's the test statistic. Okay, let's go on with question number 3. Test whether the population mean from which a random sample of size 16 is taken significantly less than 10 if the population from which the sample was taken is normally distributed with assumed mean 8.4 and variance 10.4. Oh, hold on. This one is actually new for us. This one is new. What is new? Because when the sample is taken from normally distributed, okay, and with assumed mean, okay, so they assume the mean is 8.4 and variance 10.24. So the sample is taken from, from which the population from which the sample was taken is normally distributed with assumed mean of 8.4 and variance 10.24. Let's see. So I need to kind of like dissect this. This 16 refers to my n. Okay. The population is assumed to be 10.24. The variance is 10.24, not standard deviation. Okay. And the assumed mean is 8.4. Now the thing is, this is less than 10. So which is the mean, and which is the population mean, and which is the sample mean? The thing is, what they want us to do is to test whether blah, blah, blah. The population mean test whether the population mean is less than 10. Do you see how difficult it is? Okay, so in our step 2 later on, when we do the hypothesis, what we are going to test is the mu less than 10. That's what we are testing. Okay, so in our claim, the population mean is significantly less. They're missing the words is, huh? So that these are alternate hypotheses, right? From the claim, we get alternate hypothesis in this case. Okay, less than 10 without equal sign. So the null hypothesis greater equals to 10. Okay. Then 3, that's the statistic. Z equals to X bar minus mu over sigma over square root of n. Now the X bar is 8.4 minus 10. Don't forget, this mu here always come from the constant of the null hypothesis, the null hypothesis in step 2. Okay, and then because they tell us that the population comes from is normally distributed with mean 84 and variance 10.24. Oh, by the way, if that's the variance, what is the standard deviation? That will be the square root of this. 10.4. I think that's 3.2. I think that's 3.2. Yeah, it's 3.2. So it's 3.2 over square root of 16. And then I will compute. I get exactly -2. You need to try it yourself, though. Don't, I mean, it's later on you will see it has a lot to do with your calculator also. You need to know how to use your calculator. Okay, so for now, I will stop the lecture here. Up to here, we learn step 1 to 3. Now, how about the rest? I will continue next week. We will continue on later part next week. Okay, basically, we will do step 4, step 5, and on. Now, I will leave it here for you to read. Okay, for you to read. You don't need to do the examples, though. Yeah, We will go back to step 4, 4, 5, 6 next week. And I have another continuation of this procedure. Okay. Now, why do I stop here right now? Let me delete this one. Why do I stop here? Because I want to show you how to download how to program your calculator. Okay, let's take a look on my browser. This is still recorded, right? Okay. Now you go to YouTube. And then I would like you to search for chi-square. TI-84. Chi-square TI-84. And then actually programming. Who is that? Okay, who is that? Oh, you know what? No, no chi-square. I forgot one word. Inverse. Inverse chi-square TI-84 program. Boom. Okay. It's this one here. This one. It's this one here. Okay, I want you to watch this. Yeah, inverse chi-square function is not in our TI-83 nor in TI-84. So we need to do programming. Okay, you can do this at home. Try to follow this video. Okay, but we will need this later on next week when we do confidence interval for population variance or population standard deviation. Okay, yeah, I will try to, let me get the coding. Oh, here, it's up here. Okay, this is the link. I will post it on our announcement, but I would like you to actually watch this video, do it at home, okay, and be ready by next week, okay? If next Friday you don't have this yet, okay, then try to come to my office hour, let's say, try to go online during my office hour, and then I try to help you during the office hour, okay? Yeah, I will post this in our, where do you want me to post this? I think in the announcement or in the lecture video, I mean in the discussion board. I think I will put it in both. Yeah, I think I will put it in both. Okay, now don't forget, next week, you have a take-home quiz due. Let me go back to our this thing. Don't forget that next week we have, don't forget, next week we have quiz, I think that's quiz 13 and 14 due. But of course, if you can do it today or tomorrow and you are done, just upload it right away. Don't wait until 9, 10 next week. I will definitely don't want extend the time, okay? Now, it's not that you only have 10 minutes to upload it. No, you have 1 week, okay? So if you can do it today, tomorrow, or any Monday, Tuesday, if you're done, just upload it right away, okay? Oh, yeah, I purposely set it that the file has to be in PDF, okay? So I try to enforce that it has to be in PDF because I have too many students in my other class, the one who pissed me off, that they insist to make it in pictures, But then later on they complain that it takes too long time to upload. And I think that's kind of strange. They don't want to learn new thing, but they want to complain. Okay, so that's why with this class and all my classes, I start enforcing that to be in PDF. Okay, yeah, most students, don't get me wrong, most students are actually okay. In fact, the submission I get, most of them already in PDF. Okay, most of them already in PDF. It's only those couple students that makes me spend a lot more time in grading, not really grading, in actually organizing what they submit to me. And then when I organize that, when I grade it, it's most of them blank. So it takes me more time to organize their tests, their submission, than to grade it. And I was just like, no, if it happens to me when I try to grade it, then it must happen to you too, that you take more time in taking pictures, in uploading, instead of actually focusing on working on the problem, okay? Which is not nice. Well, anyway, don't forget next week you have a quiz 13-14 group and also program chi-square distribution inverse on your calculator. Okay, now the lecture from YouTube should be seen on our discussion board today. Okay, that's where I will stop. Anybody have any question?